Symbols, formulas, and sign convention. You are already familiar with the terms center of curvature, focus, and pole in a mirror. Focal length is the distance between the focus and the pole of the mirror. It is represented by F. Radius of curvature is the distance between the center of curvature and the pole of the mirror and is represented by R. The distance between the object and the pole is the object distance represented by U. Distance between the image and the pole is image distance represented by V. Object is always kept above the principal axis and its height is represented by HO. The height of the image is represented as HI. You see, the focal length, radius of curvature, object distance, and image distance are always measured from the pole of the mirror. Height of object and height of image is always measured from the principal axis. The focal length, image distance, and object distance are related by mirror formula 1 upon f is equal to 1 upon v plus 1 upon u. The term linear magnification represents the ratio of height of image to height of object. This we will be studying later on, but it is represented by Hi upon Ho. You may also come across I upon O. This ratio is equal to minus V upon U, where V is the image distance and U is the object distance. Let us see the various signs that we use for the various measurements. The spherical mirror, whether concave or convex, are placed in a Cartesian plane with x-axis and y-axis in such a way that their pole rests at the origin. Their polished surfaces are always kept towards the left. Remember, the polished surfaces are those surfaces through which the reflection takes place. Object is always kept on the x-axis towards the left. So we get the object distance is always negative. If we measure the object distance from origin to the object, the left part of the x-axis is negative and hence object distance is negative. A real image is always formed in front of the mirror, that is on the left hand side. If we measure the distance of the real image from the pole, it would come out to be negative. So image distance for real image is always negative. A virtual image is always formed behind the mirror, that is on the right hand side. Distances on the x-axis on the right hand side are measured in positive. So we get the image distance for virtual image is positive. Height of object is always positive. You see, we measure the object height from its tip on the y-axis. So y-axis above origin is positive, and hence the height of object is always positive. The height of real image is again measured from its tip on the y-axis. Y-axis below the origin is negative, so we get height of image for real image is negative. Height of image in case of a virtual image is measured from its tip on the y-axis, and we see that this distance is above the origin, and hence it is positive. So we get the height of image for virtual image is positive. Ray of light coming parallel to principal axis, falling on a concave mirror after reflection passes through focus. You see, the focus is in front of the mirror on the left hand side. So we get the focal length in case of concave mirror is negative. Ray of light coming parallel to principal axis, falling on a convex mirror after reflection diverges. It appears to come through a point which we consider focus. As you see, the focus is on the right hand side of the origin. So we get focal length in convex mirror is positive. Thank you.